Hi and welcome back. In this lecture, we're going to talk about key insight 3, social concerns of the livestock and poultry industry. Well, if you look at this graph, it shows the feed required to produce 1 kilogram of meat or dairy product. And on top, we have beef with 25 kilograms. And next, we have lamb and mutton with 15 kilograms. After that, we have pork with 6.4 kilograms, and next we have poultry with 3.3 kilograms. Then there's eggs with 2.3 kilograms, and finally we have 0.7 kilograms for whole milk. Moving on, let's talk about the protein efficiency of meat and dairy production. On top, we have eggs with 25% of protein efficiency. Next, we have whole milk with 24% protein efficiency. Then there's poultry with 19.6 efficiency. Then there's pork with 8.5% efficiency. And next we have lamb and mutton with 6.3 and beef with 3.8%. Moving on, let's discuss a bit more about the energy efficiency of meat and dairy production. So the energy efficiency of meat and dairy production is defined as a percentage of energy inputs as feed effectively converted to animal product. So on top we have whole milk with 24%. Next there's eggs with 19%. After that poultry with 13% and pork with 8.6%. And then we have lamb and mutton with 4.4%. And finally we have beef with 1.9%. So next let's look at the land use per kilogram of food product. So the highest for this is lamb and mutton with 369.81 square meters of land use per kilogram of food product. Next we have beef herd with 326.21 square meters of land use per kilogram of food product. And then there's cheese with 87.79 square meters. Moving on, let's talk about the land use per 100 grams of protein. So highest is lamb and mutton with 184.8 square meters of land per 100 grams of protein. Next we have beef with 163.6 square meters, and then we have cheese with 39.8 square meters. Moving on, let's talk about the land use of foods per 1000 kilocalories. So on top we have beef with 119.49 square meters. Next there's lamb and mutton with 116.66 square meters, and then we have cheese with 22.68 square meters. Moving on, let's talk about the greenhouse gas emissions per 100 grams of protein. On top, we have beef with 49.89 kilograms of greenhouse gas emissions per 100 grams of protein. Next, we have mutton and lamb with 19.85 kilograms of greenhouse gas emissions per 100 grams of protein. And then there's farmed prawns with 18.19 kilograms of greenhouse gas emissions per 100 grams of protein. And moving on, let's talk about the freshwater withdrawals per 100 grams of protein. So the highest three members or the top three elements is cheese with 2539 liters, nuts with 2531 liters, and farmed prawns with 2380 liters. If you take milk, it's around 1904 liters, and if you take beef, it's 1375 liters of freshwater withdrawals per 100 grams of protein. So next let's talk about freshwater withdrawals per kilogram of food product. So if you take a kilogram of cheese, the amount of freshwater needed is 5605 liters. And if you take nuts, it's around 4134 withdrawals. And if you take beef, it's around 2714. So next, let's look at the eutrophying emissions per kilogram of food product. So eutrophying emissions represent the runoff of excess nutrients, especially nitrogen-related nutrients, into surrounding environments and waterways which affect and pollute ecosystems. So on top we have beef or dairy herd with 365.29 grams, and beef herd we have 301.41 grams, and then there's fish with 235.12 grams, and if you take lamb and mutton it's around 97.13 grams. So after that, let's talk about the eutrophying emissions per 100 grams of protein. So on top of this list is beef or dairy herd with 185.1 grams. Then there's beef herd with 151.2 grams, and lamb and mutton come around at 48.5 grams. So moving on, if you look at this graph, 6% of the global greenhouse gas emissions come from food losses and waste. So emissions from food that has never been eaten accounts for around 6% of the total emissions. That includes lost in supply chains as well as consumer waste and also food eaten. So food production is responsible for around 26% of the annual global greenhouse gas emissions. So moving on, we have a very interesting graph. So meat consumption versus GDP per capita in 2017. If you look at this graph, the top two countries, which is Hong Kong and the United States, a very high GDP per capita as well as meat supply per person more than 120 kilograms per person per year. As all the other countries in the world go towards developed economies and developed countries, the problem is going to get worse and worse because there will be a very high demand for meat supply per person, and also we need to come up with much more sustainable and environmentally friendly practices to ensure that we meet those demands. And moving on, if you look at this graph, global land use for food production, 29% of land of the Earth's surface, and there's 71% of the ocean. And out of that 29% of the land, only 71% is considered habitable land, and around 10% is glaciers, and then we have 19% of barren land. So out of that 71% of habitable land, 50% is used for agriculture, 37% is used for forest, and 11% is shrubs, and then around 1% with urban and build-up land, 1% with freshwater and things like that. So out of that 50% which is used for agriculture, 77% is used for livestock, which is meat and dairy production. That's around 40 million square kilometers, and around 23% is used for crops. So if you look at the global calorie supply, around 18% is provided by the livestock and the meat and the dairy industries, and 82% is provided by plant-based food. And global protein supply, 37% comes from meat and dairy, while 63% come from plant-based food. So those are a few key insights as far as social concerns of the livestock and the poultry industry is concerned. I'll see you on another lecture.